Good day, students! In this video, we will be discussing the theorems on triangle inequalities. But before that, let me introduce myself. I am Myra Naraha, a third-year college student taking a Bachelor of Secondary Education major in Mathematics. Take the challenge. We will illustrate theorems on triangle inequalities. But in this video, we will only focus on triangle inequality theorem. So I have here triangle ABC. Let us identify the angles and the opposite sides. So in angle A, the opposite side is BC. In angle B, the opposite side is AC. In angle C, the opposite side is AB. And now let us identify the measurements of each angles and the opposite sides. Angle A is equal to 75 degree, angle B is 60 degree, angle C is 45 degree. And the opposite sides, BC is 14, AC is 10, AB is 8. Now, given all the measurements of each angles and opposite sides, let us now identify the largest angle, smallest angles, longest side, and the shortest side. The largest angle is angle A. The smallest angle is angle C. The longest side is BC. The shortest side is AB. As you can see that angle A as the largest angle, it is the opposite of the longest side. And also the smallest angle is the opposite of the shortest side. So this concept is related to the theorem 1, which is side angle inequality theorem. It states that if one side of a triangle is longer than the second side, then the angle opposite the longer side is larger than the angle opposite the second side. The next theorem, which is the angle side inequality theorem, it states that if one angle of a triangle is larger than the second angle, then the side opposite the larger angle is longer than the side opposite the second angle. So meaning, in theorem 1, if a triangle has an unequal sides, the opposite of the longest side is always the largest angle. And also in theorem 2, if the angle is the largest, the opposite of that angle is the longest side. Now let us try to identify the largest angle to smallest angle by applying the triangle inequality theorem 1 given only the measurement of the sides. So in the given, if side BC is the longest side, meaning the opposite angle of this side is the largest angle, which is angle A. And also side AB is the shortest side, meaning the opposite angle of this side is the smallest angle, which is angle C. So these are the order. The largest angle is angle A, the larger angle is angle B, and the smallest angle is angle C. Now let's try to identify the longest side to shortest side, given only the measurement of the angles by applying the triangle inequality theorem 2. So as you can see, angle A is the largest angle, meaning the side opposite of this angle, which is BC, is the longest side, and angle C is the smallest angle. So therefore, the side opposite of this angle, which is side AB, is the shortest side. So this is the order. The longest side is side BC, the longer side is side AC, and the shortest side is side AB. Now let's try to answer this. Give the longest side of each triangle. Now we're going to identify the longest side of each triangle, but it has a missing value. Angle A has the missing measurement, missing value, we are going to identify first what is the measurement of angle A for us to be able to identify which is the largest angle, to identify which side is the longest. So to identify that, we are going to find the difference between 180 and the sum of these two remaining angles. Since the measure of the interior angles of the triangles is always 180 degrees. So 180 minus 50 plus 70 is 60 degree. So therefore, 60 degree is the measure of angle A. Now let us identify which of these three angles is the largest. So the largest angle is angle C. So therefore, the side opposite of this angle, which is AB, is the longest side. Now let's have this another triangle. It's triangle D, E, and F. Now we are going to do the same as what we did to triangle ABC. We are going to identify the measurement of angle E by knowing the difference of 180 degree and the sum of 59 degree and 70 degree. So 180 minus 59 plus 70 is 51 degree. So angle E is 51 degrees. So which of these three angles is the largest? It's angle F. So therefore, the side opposite of this angle is the longest side, which is side DE. Now let us have this last triangle. In this triangle, we need first to identify the value of x, to identify the value or the measurement of these two angles. But first, we are going to identify the difference between 180 degree and 40 degree. So it's 140. So 140 degree is the sum of these two angles. So we're going to add these two values in these angles. So 3x plus 60 plus 2x plus 45 is equal to 140. So we're just going to add the same terms. It's 5x plus 105 is equal to 140. Now we're going to transpose 105. So 5x is equal to 140 minus 105. So 5x is equal to 35. Divide both sides by 5. So x is equal to 7. Now let's substitute the value of x to 3x plus 60. So 3 times 7 plus 60 is equal to 81 degree. So the value of angle G is 81 degree. Let's substitute again the value of x to 2x plus 45. 2 times 7 plus 45 is equal to 59 degree. So therefore, the value of angle I is 59 degree. Now let's identify which of these three angles is the largest. So the largest angle is angle G. So therefore, the side opposite of this angle, which is side HI, is the longest side. And now let us have the last theorem. I have here angle ABC. First, let us pair any sides. So the first pair is AB and the third side is C. The second pair, it's AC and the third side is B. The last pair is B and C and A. So now let us identify the values or the measurements of these sides. So side A is 6, side B is 9, side C is 11, side A is 6 again, C is 11, B is 9, B is 9 again, C is 11, and A is 6. Now we're going to identify the sum at these pair sides. and we're going to compare it to the third side. Now 6 plus 9 is 15. The second pair, 6 plus 11 is 17. 9 plus 11 is 20. As you can observe, the sum of these pair sides is always greater than the third sides. And that is all about the third inequality theorem, which it states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side, meaning the sum of these paired triangles is always greater than the third side. Now let us have this example. Which of the following could be the lengths of the side of a triangle? Let us have these first side lengths. 7, 4, and 5. 7 plus 4 is greater than 5. 4 plus 5 is greater than 7, which is true. 7 plus 5 is greater than 4, which is true again. So, since these side lengths satisfy the theorem, therefore the side lengths can form a triangle. Let us now have these side lengths. 9, 11, and 2. 9, 11, and 9 plus 11 is greater than 2, which is true. 11 plus 2 is greater than 9, which is true. 9 plus 2 is not greater than 11. Since these side lengths do not satisfy the theorem, therefore the side lengths cannot form a triangle. Let us have these last side lengths. 12, 10, 12. 12 plus 10 is greater than 12, which is true. 10 plus 12 is greater than 12, which is true again. And 12 plus 12 is greater than 10. So, since these side lengths satisfy the theorem, therefore, these side lengths can form a triangle. Let us have this problem. The two sides of a triangle measure 15 cm and 9 cm. Write an inequality that represents the range of values for the possible side lengths of the third side. So, a triangle has a measurement of 15 and 9 cm. So, in order for us to identify the last measurement of the third side, we are going to use this formula. The third side is always greater than the difference of the pair sides, but less than the sum of the pair sides. X is greater than 15 minus 9, but less than 15 plus 9. So x is greater than 6, but less than 24. So all the possible values of x range from 7 to 23. Let's try to answer this. Measure of three sides of a triangle are given. Find the possible values of x. So, for us to be able to find the values or the exact measurements of these sides, we need first to identify the values of x. So, we're just going to use the formula shown in the previous slides, which is the third side is greater than the difference of the pair sides, but less than the sum of the pair sides. So, let us have 18 as the third side, since it's the only whole number. So let us compute first the difference. 2x minus x is x. So x is less than 18. Now let's compute the sum. 2x plus x is 3x. So divide both sides by 3. So x is greater than 6. Now we're just going to arrange this. So the value of x is greater than 6 but less than 18. Meaning the possible values of x are 7 to 17. Now let's check. Let us try to substitute 7 as the value of x. Now, the first pair is this side, 2x plus x is greater than 18. Substitute 7, so it's 14 plus 7. So 21 is greater than 18, which is true. Let's have another pair, 18 and 2x. Substitute 7, so 18 plus 14 is 32 is greater than 7, which is true. Let's have another pair, 18 and x. Substitute 7, so it's 25 is greater than 14, so it is true. As you can see, the value of x is 7, which is true among the given sides of the triangle. So therefore, if the value of x is 7 to 17, that is all true among the lengths of the sides of the triangle. Now let us try to check. Let us try 6 as the value of x. So let's have this pair, 2x plus x. Substitute 6, so 18 is not greater than 18, therefore it's false. Let's have 18 as the value of x. Substitute 18, it's 36 is not greater than 36, therefore it's false. So therefore 6 and 18 cannot satisfy, or 6 and 18 cannot be the possible value of x in this triangle. That's all. Thanks for watching.